In this video, we are going to look at 1975 AB2, which is in number 45 in your packet, and we are just going to look at part D here where it asks for the total distance that the particle has traveled. So we found in part A times whenever the particle was moving to the right, or we could have for part A, you didn't have to. But we look at the sign of the derivative, and when we see that the derivative is positive, that means that the particle is moving to the right. And when we see that it's negative, it means it's moving to the left. So what we see is this particle was moving to the right until it got to 2. Then at t equals 2, it switched to move to the left until t equals 4. And then from t equals 4 on, it is moving to the right again. This problem asks us, when t equals 3, what is the total distance the particle had traveled? The particle started whenever t equals 0, and it moves until t equals 3. So certainly we're going to need to find t equals 0 and t equals 3. But this particle moved to the right until, so here is t equals 0. It moved to the right. Right here is t equals 2. But at t equals 2, it turned around and started going back to the left. So it ends up here at t equals 3. So if we're just wanting to know how far it is from where it started, we would subtract the position at t equals 3 from position at t equals 0, or vice versa. But we want to know the total distance, which means we need to know how far it was from 0 all the way to t equals 2. And then we need to add the distance from t equals 2 to t equals 3. Because even though this distance was going backwards, it still counts as distance. So what we're going to do is we're going to find the position at all 3 of these places. So we're going to find x of 0, which is going to be 1/3 times 0 to the 3rd minus 3 times 0 squared plus 8 times 0, and this is just going to give us a 0. So the position at t equals 0 is 0. At t equals 2, we're going to have x of 2. So we'll have 1/3 times 2 to the 3rd minus 3 times 2 squared plus 8 times 2. This will give us 1/3 times 8 minus 12 plus 16. So that gives us 8/3 plus 4, which is 8/3 plus 12/3, which is going to give us 20/3. So our position at t equals 2 is 20/3. And then we already had to find the position of the particle at time t equals 3. That was the answer for part C. And for part C, whenever we found x of 3, there we got 6. Okay, so the position at t equals 3 is 6. So we don't have to plug that in because we already did that on part C. So what we're going to do is we're going to look at the distance that was traveled. So obviously from t equals 0 to t equals 2, that distance traveled was 20/3. And then from t equals 2 to t equals 3, the particle started moving to the left again. So what we want to do is take 20/3 and subtract our 6, which means we have to do 20/3 minus 18/3. So that would give us 2/3. So the particle moved back to the left 2/3. So our total distance, the particle moved to the right 20/3, and then it moved to the left 2/3. So our total distance going to be 22 thirds. So the particle moves 22 thirds during the time from t equals 0 to t